In this video, we will be looking at section 8.2, which covers polar coordinates. So everything we've done so far has been in the Cartesian coordinate system, which is also called the rectangular coordinate system, but it's not the only coordinate system we can use. Sometimes it's more convenient to work with an angle and a distance from the origin, which is all stuff we've done before. So that's what's going to lead us to this idea of polar coordinates. So this is what we're used to, but here's another idea. It might remind you of the unit circle, sort of, because it has your different angles in degrees and radians. So that's going to be your angle from horizontal, and then your distance from the origin is just going to be how many circles out do you count. Polar coordinates of a point are still an ordered pair, but instead of them being x, y, they are r theta, where r is the distance from the point to the origin, and theta is the angle measured in standard position. That's the normal from the positive x-axis, how far around you have to go. So we're going to start by plotting in polar coordinates. First up, we have 4, pi over 2. It's going to help if we find our angle first and then go from there. So pi over 2, that's 90 degrees. We want to go 4 units from the origin. So that's going to be going out 4 circles. 1, 2, 3, 4. That's where that point lies. Next up, we have 2, 5 pi over 6. 5 pi over 6 is right here, and we want to go out 2 units in that direction. 1, 2. Finally, we're looking at -5, 2 pi over 3. So let's start by finding 2 pi over 3. That's right here. But our r value is -5. How do you think that's going to affect where our point goes? Well, instead of going towards or outwards towards that 2 pi over 3, we're going to go the opposite direction, which is going to be towards 5 pi over 3. We're still going to go 5 units, just in the opposite direction. So 1 circle, 2 circle, 3 circle, 4 circle, 5 circle. That's what I'm looking for. As you can imagine, these points could also be plotted in the xy coordinate system, the Cartesian coordinate system. So we're going to work on converting between the two forms. The great news is you already know how to do this, we just haven't done it. To convert between polar and Cartesian coordinates, we're going to use the following relationships. Using the same triangle as we always have, x is your horizontal distance, y is your vertical distance, r is the radius, which happens to be the hypotenuse of this triangle. We get that the cosine of theta is x over r, the sine of theta is y over r, and the tangent of theta is y over x. Solving this equation for x, we get r cosine theta. Solving this equation for y, we get y as r sine of theta. And then looking at this, it's a right triangle, so x squared plus y squared equals r squared. So keep these in mind as we're working. They are also on your formula sheet. The x, y, r stuff, x squared plus y squared equals r squared, that's all in there. Your x equals r cosine theta, y equals r sine theta, it's all there. So we're going to convert from polar to Cartesian coordinates first. So going from polar to Cartesian, we want to take an r and a theta and convert it to an x and a y. Well, x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. So in this case, x will be 4 times the cosine of 7 pi over 4. You're going to want your formula sheet. 7 pi over 4 has a cosine value of square root of 2 over 2. Our y value will be 4 times, the sine value there is negative square root of 2 over 2. That means our r value is, our x value is 2 times the square root of 2, which is the simplified version. Our y value is negative 2 square root of 2. So in the Cartesian coordinate system, this point is 2 square root 2, negative 2 square root 2. Next up, we'll work with 5 comma pi. I bet you can figure this one out without even doing the math if you really think about it. But we'll do the math just to prove that it's true. So x will be our r value 5 times the cosine of pi. The cosine of pi is negative 1. So our x value is negative 5. Our y value is 5 times the sine of pi, which is 0. Means our y value is 0. That means this point is located at negative 5 comma 0, which should make sense because the angle pi is the negative x-axis, and we went 5 units that way. Finally, we have negative 2 comma 2 pi over 3. So our x value will be negative 2 times the cosine of 2 pi over 3. The cosine of 2 pi over 3 is negative 1/2. 2 times negative 1/2 is 1. Our y value will be negative 2 times the sine of 2 pi over 3, and the sine of 2 pi over 3 is square root 3 over 2. And that simplifies to a negative, the 2's cancel out, square root 3. So this is located at 1 comma negative square root 3. Now let's try going the other way. Starting with Cartesian points, we want to switch to polar. First up, we have 5 comma 3. We have to use the fact that x squared plus y squared equals r squared, so that we can find r. So that'll be 5 squared plus 3 squared equals r squared. 25 plus 9 is 34. So r will be the square root of 34. Now we need to find theta. 5, 3, that means we have a positive x and a positive y. That means we're going to be in quadrant 1. Yep, the quadrant stuff is still around. We can either use the fact that sine of theta is y over r, or cosine of theta equals x over r, whatever works for you. I'll just use sine because that's what I said first. The sine of our angle theta is equal to our y value 3 over our r value square root of 34. We're not in triangle world anymore, so let's switch to radians. The inverse sine of 3 divided by the square root of 34 is 0.5404. We have an r and we have a theta. Whoops. This is theta because I took the inverse sine of it. So our ordered pair is the square root of 34 comma 0.5404. Next up we have negative 4 comma 9. We start by finding our r value. Negative 4 squared plus 9 squared equals r squared. That's 16 plus 81. So r is the square root of 97. This time we have a negative x value and a positive y value. That puts us in quadrant 2. So we have to make sure we come up with a quadrant 2 answer. If I use sine, then the sine of theta is equal to 9 over the square root of 97. So that tells me theta equals 1.1526. But that's in quadrant 1. we said we wanted quadrant 2 because we have a negative x value and a positive y value. So if I take pi minus what they just gave me, I get that my theta in quadrant 2, which I'm looking for, is 1.9890. So this is the ordered pair square root of 97, comma 1.9890. Finally, we're looking at 1 comma negative 6. 1 squared plus negative 6 squared is r squared. That means r is the square root of 37. We have a positive x and a negative y. That puts us in quadrant 4. So if we use sine, we get the sine of theta is equal to negative 6 over the square root of 37. The inverse sine of negative 6 over the square root of 37 tells us that theta is equal to negative 1.4056. That's a negative angle, but that's okay. We can use a negative angle. If for some reason they don't want a negative angle, you can add 2 pi to this, and it'll give you the positive version of that angle. It ends up in the same place. So since I have an r and a theta, we get the ordered pair square root of 37, comma negative 1.4056. It would be just as accurate to say the square root of 37, comma 4.8775, because that lands in the same place when you plot it. Now we've seen some interesting graphs in the Cartesian coordinate system. We've looked at parabolas, we've looked at cubics and quartics and quintics, all these different polynomial functions. We've looked at rational functions, but probably, at least in my mind, the coolest thing about polar coordinates are the graphs. Don't worry, we're not going to be focusing on these at all, but I do want to show them to you because they are that cool. We'll use technology if we want to graph them. If you have a graphing calculator, I can show you how to use it. Otherwise, feel free to go into Desmos and just play around with it. It is a blast. The last thing we're going to do in this section is convert equations. So if we want to take a Cartesian equation and convert it into a polar equation, we can do that, or vice versa. So first up, we have x equals 3. I want to take it from being in terms of x and y and put it into terms of r and theta. So what do we know about x? Well, x is equal to r times the cosine of theta. So if x equals 3, then r times the cosine of theta is equal to 3. And you'll notice over here our polar equations usually start with r equals. So I'm going to get the r by itself. R is equal to 3 over the cosine of theta. Next up, we have x squared plus y squared is equal to 3x. We know that x squared plus y squared is r squared. So that one's not too bad. That's equal to 3 times what we know x is. X is r times the cosine of theta. Now I have r's on both sides of my equation. Let's see if we can get them together. I'll subtract 3r cosine theta from both sides. They now have a greatest common factor of r. If I factor out the r, then we have r times r minus 3 cosine theta is equal to 0. So either r equals 0 or r minus 3 cosine theta equals 0. I want you to think back to when we were plotting these polar coordinates. R equals 0 means we have not moved at all from the origin. So we are sitting at the origin. That's just 1 point. That's not a graph. So we're just going to toss that one out. Solving this one for r, we get r is equal to 3 times the cosine of theta. That's what we're looking for. Next, we're going to go the other way. If r is equal to 2 times the cosine of theta, we want to switch this into terms of x and y. This one's kind of cool. R is equal to 2 times, what do we know about the cosine of theta? That's x over r. If I multiply both sides by r, we get r squared is equal to 2x. Now we know r squared is x squared plus y squared. And that's just how we're going to leave it. X squared plus y squared equals 2x. You'll notice it looks similar to this one. Finally, we're looking at r equals 6 over cosine of theta plus 3 sine of theta. That one looks super complicated. I'm going to start by getting rid of the fraction by multiplying both sides by this denominator. So I would have r times the quantity of the cosine of theta plus 3 sine of theta is equal to 6. Now let's switch out sine and cosine for what we know they are. So this is r times x over r plus 3 times y over r is equal to 6. If I distribute my r through the parentheses, r times x over r is just x. R times 3y over r is just 3y. And that's equal to 6. That is in terms of x and y, so we're done.